this is 2018 end of year Sec 1 Express paper. Okay, so let's go on to the chemistry section, section C. Okay, so the diagram below shows the results of an experiment involving 3 dyes. So I got 3 dyes, blue, yellow, and red, and 4 colored substances D, E, F, G over here. Okay, now name the most soluble dye, because these 4 are colored substances, these 3 are dyes, so we're looking at this 3 over here. Now the most soluble dye will be the one that has traveled the furthest. Okay, that traveled the furthest. Therefore, you can see over here, the red dye has traveled the furthest, from here all the way to this side. And the most soluble substance is actually red. State the colored substance that is a pure substance. So these are the 4 colored substances over here. Which of them are pure? So for it to be pure, generally you should see only one spot, okay, or one component. So if you look through at all of them, this one has 2, 2, 1, 2. 2 components, 1 component, 2 component, 2 components over here. Therefore, F is the pure substance because it only has 1 component. Okay? Or you can say there's only 1 spot. Now, given that blue dye is an unapproved coloring in the industry, suggests which substances are safe. So let's start from, because this is unapproved, anything with blue is considered unsafe. So how do you know whether the substance has blue? Look out for something like this. Okay, look out for a spot that's at this level. Okay, so realize G contains the blue dye. So G is considered unsafe. Hence, what is safe? D, E, and F. So which colored substances are safe to consume? Answer is D, E, and F. Only G is unsafe. Next, the chemical diagram below shows 5 different atoms labeled P, Q, R, S, and T. These are not chemical symbols of an element. Okay, they are just the symbol of these 5 different atoms. So which letter or letters represents in part A, an atom with atomic number of 6. Atomic number is the same as the proton number. So I just look out for which one has a proton of 6. Answer is S. Next, I want an atom with a nucleon number of 7. Nucleon number is actually the proton plus the neutron, because this is the number of particles in the nucleus. So that's why it's proton and neutron. Hence, I just need to find something that adds up to 7. The answer is over here. Proton, neutron, 3 plus 4, 7. So answer for this is P. Part C, 2 different isotopes of the same element. So if they are the same element, they must have the same number of protons. Now, because they are isotopes, so we also take note they must have the same number of protons as mentioned. They must also have the same number of electrons. So therefore, if you look at all these possible answers here, 3, 6, 5, 5, 7, so answer is only these 2. So these 2 are isotopes. So R and Q are isotopes. Okay. Next, the chemical symbol for fluorine is F919. Write electronic configuration for fluorine. So before you can write electronic configuration, you must know how many subatomic particles are there inside. So normally you will do the PEN, proton, electron, neutron. The 9 here tells you there are 9 protons, and because this is an atom, we assume that this is an atom, you will also have 9 electrons because they are electrically neutral. So we are applying the idea that atoms are electrically neutral, hence the number of protons and electrons must be the same. Neutrons is taking the top number, the nucleon number minus the proton number, you will get 10. To find out the electronic configuration, your focus will just be on the 9 electrons. Take note, first shell can only hold, so electrons are arranged in shells. The first shell can hold 2, subsequent shells can hold 8. So first shell hold 2 electrons, I'm left with 7 more, because 9 minus 2, I left 7. All 7 will be able to fit into the second shell. Therefore, the electronic configuration for fluorine is 2, 7. Draw the atomic structure for fluorine. Okay, how to draw? So you know that is 2, 7, and I want atomic structure. So therefore, I want to label neutrons and protons properly, right? So let's draw the nucleus. The nucleus consists of 9 protons, 10 neutrons. Next, because the electronic configuration is 2 and 7, so I will have one shell here with 2 electrons. I will have another shell here with 7 electrons. Okay. Typically, you shouldn't draw electrons like this. You should actually do up, down, left, right. So let's say I draw properly. Let's say I draw in the correct sequence. 7 electrons. 1, 2, 3, 4, 5, 6, 7. So this is actually how you should go about drawing electrons. Always in a certain order. Okay, you cannot always pair them up. Always go by the up, down, left, right order. Okay. Next. Now let's look at this question here. Diagrams A, B, C, D, E, F in the diagram below represents particles in different substances. Each letter can be used once, more than once, or not at all. Okay, so we got all this. Take note, carbon is this dark circle over here. Oxygen is the white one. Hydrogen is the green one. Which diagrams A, B, C, D, E, F represents methane? So CH4, that means it must be a dark circle, followed by grey one. Grey, grey, grey. You should see something like this. And do you realize it's the only one methane? So it must purely contain methane. Therefore, answer for first one is D. You can see here. That's why I said, why E cannot? E got methane, so E, yes, it has methane. But you realize E also has CO2. So therefore, E actually is not purely methane. Therefore, E cannot be the answer. Therefore, answer for part 1 is D. Which one consists of a diatomic element only? Diatomic means 2 atoms joined together. And because it is an element, so it must be the same type of atom. So therefore, the answer would be F. Okay, for part 2. Why? Can you see this is a diatomic element? Now, so I say, C also diatomic, C diatomic. Now, but they only want a diatomic element. Therefore, C cannot be the answer. Hence, we are down to only F. Which one is a triatomic compound? So compound means, okay, triatomic compound. Let's combine the whole thing together since we explain a bit more. It means 3 atoms joined together. Okay, and I must have at least 2 different elements, because compounds are 2 or more different elements chemically combined. So therefore, the only answer is A. Okay, because this is a triatomic compound. Now, to take note, it's the same idea because they only want a triatomic compound. Therefore, the only possible answer is A. A mixture of compounds only. Okay, so I only want a mixture of compounds. So therefore, B is out because it got element. C is out of this element. F is out. D consists of only one compound, so this is not a mixture. Therefore, the only possible answer is E. Consists of 2 different compounds, CH4 and CO2. So therefore, this one is E. Okay, part 4 is E. Next, part B, determine the number of atoms of each element present in the following substance. So C7H8O. So I got 3 carbons. C. That's 3 carbons. There was 3 carbons. Sorry. I got 7 carbon. I got 8 hydrogen. Okay. And then I got 1 oxygen. Okay. So this is the sequence here. Next one. Okay. This one you realize is a bit more complex. So let's start off by looking at how many elements are there first. I got Ba, barium. Okay, oxygen OR. First I got barium, Ba. Next I got nitrogen, N. Next I got oxygen, O. Next, I got hydrogen, H, and then I got oxygen again. Okay, so good. Now, this dot here tells you that they are all joined up together, but the 2 here represents 2H2O. Okay, this 2 here represents there's 2 nitrate over here. So if I were to just do the whole thing up, this means the formula looks expanding out. So I got Ba, I got 2 nitrogen, I got 6 oxygen. Okay, so I've expanded out here already. Now 2H2O tells me that I got 2 water, right? So that means I must have 4 hydrogen. So H2 times 2. Okay, so I shouldn't draw like that. So that means I got H, 4 of them. O, I got 2 of them. So if I were to look at all this expanded out with all the little numbers at the bottom right, so I have 1 barium, 2 nitrogen, 8 oxygen, and 4 hydrogen. So that's how you go about counting the number of atoms of each element. Last one, part C. This one, if you remember, you can get the full marks. Okay, but if you, of course you don't remember, it's going to be difficult. So key way to remember is I always tell my students, proton, think of it as proton represents positive, so relative charge plus 1. Neutron, neutral, the charge will be 0. And electron, obviously, must be opposite of proton, that's 1. Okay? So charge, I'll go by proton, neutron, then electron. Because positive, proton, neutral, neutron, 0. Electron must be the opposite of proton, so it's -1. In terms of relative mass, just take note, only those in the nucleus will have a relative mass of 1. So what's in the nucleus? The proton and neutron. Electron is outside orbiting, so this is the one where you have to write the 1/1840. Location in atom, this is in the nucleus. Right? Neutron also in the nucleus. Okay, this one is on the electron shell. I kept moving rapidly around the nucleus. Right, this is whatever that's currently in your syllabus. Actually, if you realize, you read out a bit more, electrons are a bit more complex than just moving around the nucleus or just on the electron shell itself. Next, 4, quite another question. 4, the boxes below will contain description of 4 different substances, K, L, M, and N. So you're supposed to classify them as element, compound, or mixture. So let's start. Solid K melts, cannot be made into a simpler substance. Whenever you see this phrase, it tells you that it must be an element. Next, a chemical reaction takes place and heat is liberated when this white solid L is formed. So, a chemical reaction happens when L is formed and there is energy exchange or energy change. So you look at your chapter 4, when there's an energy change involved in forming the substance, typically this would be a compound. Okay, next, blue liquid M distilled and then a colorless liquid is collected. So you can see there's a difference in physical property. Okay, that's the first thing you observe. Second thing, this blue liquid M is separated into 2 different things by a physical method, physical process. Okay, so separated by physical process. So therefore, this whole thing here, because separated by physical process, there are 2 different types of liquid here. You can see by the difference in physical property. Therefore, M is a mixture. Last one, white solid M can be separated into 2 different substances by adding water and filtering. This is once again separation by physical process. So therefore, this is also a mixture. Okay, quite simple for marks here. B part 1. What do you understand by the term isotopes? This is actually just asking you definition. So isotopes, okay, note there's an S over here. Therefore, isotopes are atoms. Okay, atoms must at least have more than 1 here, must at least 2 and beyond, of the same element. Then scroll down a bit, with same number of protons and electrons, but different number of neutrons. Okay, so just take note, this is just purely definition itself. Now let's determine the proton, electron, neutrons of these isotopes. It's actually quite simple. Even if you do not know what they are if you do not know that they are isotopes, based on the proton and the nucleon number provided, you can also find out how many proton, electrons, and neutrons there are. So, because the proton number is 8, it definitely must have 8 protons. And because you can see here, they got, let's assume that they are atoms. So the number of protons and the number of electrons must be the same. To find neutron, you actually take the nucleon number minus the proton number. Same thing here, nucleon minus the proton, you get the number of neutrons. So this is part 2, quite simple, 3 marks. Question C. The diagram below shows a setup that can be used to separate pure water from seawater. So you can see this setup over here with this condenser. I think most of you will guess this is distillation. But distillation, there are 2 types. They are simple and fractional. So you realize this one here does not have a fractionating column. So therefore, this must be a simple distillation. Okay. Next, predict the reading on the thermometer during this separation. So because this is seawater, the liquid that's going to come up here is actually water. And the thermometer actually measures the boiling point. So since it measures the boiling point and water is the one that's actually being boiled away, so therefore the prediction on the thermometer reading will be 100 degrees Celsius. Okay, so that's the end for section C.